Hi everyone, welcome to Dr. Peiris classroom. This lecture is a part of the lecture series of a Precalculus course, and today's lecture is about complex numbers. So in this lecture I will explain you these topics. First I will explain you what is an imaginary number, then what is the standard form of a complex number. Then I'll show you how to plot complex numbers. Then we will discuss how to add, subtract, multiply and divide complex numbers. The first one is the imaginary number. So what is an imaginary number? The imaginary number is defined as the square root of -1 and it has given the symbol I. So the imaginary number I is equal to square root of -1. And by using the properties of radicals, you will find that I squared is equal to -1. So when do we use these imaginary numbers? Whenever you want to find the square root of any negative number, the answer can be written using I. So let's see an example. So the first example is how to find the square root of -25. So to find the square root of -25, you can break down square root of -25 as this: square root of 25 times the square root of -1, and the square root of 25 is 5. And what is the square root of -1? We said that that is the imaginary number I. So square root of -1 is I. So you can see that the answer came in terms of the imaginary number I. So the square root of -25 is equal to 5I. Let's see the next example, square root of -9. So you simplify it as square root of 9 times square root of -1. And the square root of 9 is 3. Again, the square root of -1 is I. So the square root of -9 is equal to 3I. Now let's see what is the standard form of a complex number. The standard form is A plus BI, where A is the real part and BI is the imaginary part of the complex number. And now let's see how do we use this standard form. So I want to express the square root of -16 in the standard form of a complex number. So you first write down the square root of -16 using I. So we follow the same method that we learned in the previous examples. So square root of -16 can be simplified as square root of 16 times square root of -1. And the square root of 16 is 4, square root of -1 is I. Now this is not in the standard form because the standard form is A plus BI. So if our answer is 4I, which means the real part is 0. So A is equal to 0. So if we want to write the answer in terms of the standard form, we write it like this: 0 plus 4I. So this is the standard form. Now let's see how do we plot complex numbers. So to plot the complex numbers, we need to use the complex plane. So in the complex plane, the horizontal axis is the real axis, basically correspond to the real part of the complex number. And the vertical axis is the imaginary axis, and we use the letter I. Or basically that correspond to the imaginary part of the complex number. Now let's see a few examples. So how do we plot -3 plus 4I? So what is the real part? -3. So we go to the real axis and then find where is -3. So here is -3, and the 4I is the imaginary part. So on the imaginary axis we mark where the 4 is. So here is the point for the complex number -3 plus 4I. So this is the point for this complex number. Now let's do the second one, -1 minus I. So where is -1? -1 is right here on the real axis, and -I. Where is -I? So you can rewrite this complex number as -1 minus 1i. So if you do that, you see the imaginary part is basically -1. So -1 is here. So which means our complex number is right here at -1 comma -1i. So this is the complex number, -1 -i. So this is how you plot complex numbers. Now let's see how do we add and subtract complex numbers. So what do we need to do? Basically you need to combine the real parts together and the imaginary parts together. So let's see the example. So we are going to add 3 plus 4i and 2 minus 5i. So 3 plus 4i plus 2 minus 5i. So let's add them. So what are the real parts? 3 plus 2 is 5. The imaginary parts, 4i minus 5i, you combine the like terms. 4i minus 5i is -i. So this is what we get as the answer, 5 minus I. The next example, subtract 3 plus 4i from 2 minus 5i. You have to be very careful with the words of these type of questions. This says from 2 minus 5i. So which means the first complex number is 2 minus 5i, and we are going to subtract 3 plus 4i from that. So you have to make sure that you put parentheses for 3 plus 4i, so you don't miss any negative signs. Now before we combine the real parts and the imaginary parts, you need to distribute the negative sign in the middle. So we going to distribute these parentheses. The first one stays as same, and the next parentheses need to be multiplied by a negative sign. So it becomes -3 minus 4i. Now combine real parts. 2 minus 3, -1. Then combine the imaginary parts, -5i minus 4i, which is -9i. So this is the final answer. So the only thing that you need to be careful when you subtract the complex numbers, so always put the parenthesis for the second complex number, so you will not miss any signs when you do the calculations. The next part is how to multiply complex numbers. So this is about multiplying a complex number by a real number. So whenever you want to multiply a complex number by a real number, you need to distribute the parentheses, or basically use the distributive property. Let's see the first example. Find the product of 2 and 3 plus 5i. So basically you're going to multiply 3 plus 5i by 2. So we do 2 times 3, 6, and 2 times 5i. 2 times 5i is 10i, and that's all. So you will find the product. So we're going to do the same thing for the next example. Find the product of -2 times 1 minus 5i. So -2 times 1 is -2. -2 times -5i is +10i. Make sure you use the signs properly, the rules of multiplication of the signs. This is how you multiply a complex number by a real number. Now let's see how do we multiply a complex number by another complex number. So again, we're going to use the distributive property or the FOIL method that you have learned. And then after you distribute the parentheses, you need to combine like terms and then simplify your final answer. So let's see the first example. So we're going to multiply the two complex numbers, 4 minus 3i and 2 plus 5i. So basically you need to multiply the second parentheses by 4 first, like this. 4 times 2, 8. 4 times 5i is 20i. So this is what you do. First you multiply the second parenthesis by 4. Then again you're going to multiply the second parenthesis by negative 3i. So negative 3i times 2 is negative 6i, and then negative 3i times 5i is negative 15i squared. So make sure that you put the signs properly, as well as when you have I times I, it becomes I squared. And then you're going to combine like terms. So 8 plus 20i minus 6i, these are like terms. So 20 minus 6 is 14i, and then we have minus 15. What is I squared? We learned that I squared is equal to negative 1. So make sure that whenever you see the I square anywhere in complex number calculations or simplifications, you substitute negative 1 for the I square. So we have 8 plus 14i minus 15 times negative 1 becomes positive 15. Now we combine the real parts. So we have 8 plus 15, which is 23, plus 14i. So this is the final answer. So when you multiply a complex number by another complex number, your answer would also be a complex number, or it could be just a real number, or just an imaginary number. Let's see the next example. So we're going to multiply 1 minus 3i and 2 minus 3i. So we do the same method. 1 times 2 is 2. 1 times negative 3i is negative 3i. Negative 3i times 2 is negative 6i. And then negative 3i times negative 3i is positive 9i squared. And then we combine like terms. 2 minus 3i minus 6i is minus 9i, and plus 9i square, we substitute negative 1. So 2 minus 9i plus 9 times negative 1 is negative 9. So 2 minus 9i minus 9. So we combine now the real parts. 2 minus 9 is negative 7 minus 9i. So this is the final answer. So this is what you do when you have to multiply two complex numbers. Make sure that you multiply each and every term in the second parenthesis by each and every term in the first parenthesis, and then substitute negative 1 for the I squared, and then at the end you combine the real parts together and the imaginary parts together. Now so before we learn how to divide complex numbers, we need to understand the concept called complex conjugate. So how do you find the complex conjugate of any given complex number? The complex conjugate of a complex number which is in the form of a plus bi is equal to a minus bi. So if the complex number is a plus bi, the complex conjugate is a minus bi, or vice versa. You basically switch the sign in the middle to find the complex number. So when a complex number is multiplied by its complex conjugate, you will get a real number as your answer. And similarly, when a complex number is added to its complex conjugate, your answer is also a real number. Now let's see a few examples. So find the complex conjugate of 2 plus 5i. So what is the complex conjugate of 2 plus 5i? 2 minus 5i. You switch the sign, that's all. The next example, what is the complex conjugate of negative 3i? So negative 3i, if you want, you can write it in the standard form. So negative 3i can be written in the standard form as 0 minus 3i. So which means what is the complex conjugate? is 0 plus 3i, or basically the complex conjugate is equal to 3i. So this is how you find the complex conjugate. You simply switch the sign in the middle. Now let's see how to divide complex numbers. So to divide complex numbers, you need to follow these steps. First, you need to write the division as a fraction, and then you find the complex conjugate of the denominator. So you need to find the complex conjugate of the denominator, and then you're going to multiply both numerator and the denominator by the complex conjugate of the denominator, and then we combine like terms and then simplify. So let's see some examples. So the first example, divide 2 plus 3i by 4 plus I. So first you're going to write it as a fraction. So what goes to the numerator? 2 plus 3i, and we divide this by 4 plus I. Now what is the complex conjugate of the denominator? The denominator is 4 plus I, and then the complex conjugate is 4 minus I. So you're going to multiply both the numerator and the denominator by the complex conjugate of the denominator, which is 4 minus I. 4 minus I. So you multiply both numerator and the denominator by 4 minus I. Then you need to simplify the numerator and the denominator. So how do you simplify the numerator? So in the numerator we have a complex number multiplied by another complex number, and we have learned how to do that multiplication. So you're first going to multiply by 2. So 2 times 4 is 8, and then 2 times negative I is negative 2i. So you do one at a time, and then we do 3i times 4, which is 12i, and then 3i minus I is minus 3i squared. So that is the numerator. Now let's see what we have on the denominator. And on the denominator we have 4 plus I times 4 minus I. So in this case it is a difference of squares. If you remember the difference of squares, a minus b times a plus b can be written as a squared minus b squared. So this is the difference formula. So in the denominator we have a difference 4 plus I times 4 minus I. So which means we can simply write it as a squared minus b squared. So it is going to be 4 squared minus I squared. So for the denominator you don't need to expand all the terms using the FOIL method, because the denominator basically follows the difference formula. So it follows this difference formula, which means you can simply use that rule to simplify the denominator. So always in these division questions, the denominator is going to be the square of the first term minus the square of the second term. Now let's simplify the numerator. So we have 8 minus 2i plus 12i is plus 10i, minus 3i squared is negative 1, and 4 squared is 16 minus I squared is again negative 1. Make sure that you put a parenthesis when you substitute negative 1 for the I squared. Now let's simplify this. So on the numerator we're going to have 8 plus 3, which is 11, plus 10i. And what is on the denominator? 16 plus 1, which is 17. So you can write this in the standard form. So you divide each term in the numerator by 17. So 11 over 17 plus 10 over 17 I. So this is the standard form. So this is how you divide complex numbers. Let's see the next example. So we're going to divide 3 plus 2i by 1 minus I. So the complex conjugate of 1 minus I is 1 plus I. So you multiply both the numerator and the denominator by 1 plus I. So what is on the numerator? So 3 times 1 is 3, 3 times I, 3i. Then you're going to multiply by 2i. 2i times 1 is 2i, 2i times I is 2i square. And then the denominator. So we're going to have the difference formula. So 1 is square minus I square. Now let's simplify the numerator. So 3 plus 2i plus 3i, which is 5i, plus 2i squared is negative 1. So 1 minus again I squared is negative 1. So what's on the numerator? 3 minus 2 is 1 plus 5i. Denominator is 1 plus 1, which is 2. Now we write this in the standard form. So 1 over 2 plus 5 over 2i. You divide both 1 and 5 by 2. So this is the final answer. So this is what you do for the division of any complex numbers. So make sure that you multiply by the complex conjugate both the numerator and the denominator, and then when you simplify, make sure you substitute negative 1 for the I square, and then write your answer in the standard form. So that's all for this lecture about complex numbers. And if you want to find more lectures on this pre-calculus class or any other classes that I have on my YouTube channel, please visit my YouTube channel, Dr. Peiris Classroom, as well as you can visit my website www.drpeirisclassroom.com. So there you can find all the videos and all the classes that I have on YouTube with more information. So thank you everyone, thanks for listening. So I'll meet you again with another video of a different lecture. Bye.